if 3x minus y equals 12, then what is the value of 8 to the power of x divided by 2 to the power of y?
I really liked that one.
Do you want to do it?
I don't know if I even know how to do it. I
I'm
wanted to
actually
play
thinking
around
that
with it and figure it out.
Yeah. Why don't we just talk through this one, because I'm actually thinking the same thing.
Let's do it together.
Okay.
So 8 to the power of x divided by
2 to the power of y.
So we're looking for the value.
This sounds like an SAT question to me. This is
does.
just something you'd see.
Honestly, I'm doing a lot of these problems right now.
Yeah.
So that's why I was kind of like, ooh, I'll do this one.
Ooh, this one looks tricky. Good practice.
All right, so we got 8 to the power of x divided by 2 to the power of y. My first thought is maybe we solve for x or y in terms of the other, or maybe we kind of manipulate this right here.
To have the same base.
Same base. So
I was actually thinking both of them would be valuable.
Why don't we try that, like messing with this first, and then see what it looks like.
Okay.
Kind of go from there. So when you say same base, you mean
2.
We want the 2, right?
Yeah.
So think about, this is always a tricky idea to teach.
Oh gosh,
8,
I know.
Yeah, 8, how could you write 8 with a base of 2? So what we're asking is 2 to the power of what is 8? And that would be 2 to the power of 3. And this is kind of another thing, while I think, Becca, I think you're the same way. I really try to avoid too much memorization. There are just some things in math that you really need to memorize, otherwise you just don't see it.
Right.
Right? Like, I know 2 to the power of up to like 7, like right off the top of my head.
Yeah.
Because when I see that number, I'm like, oh, it's 2 to the power of 7. I can rewrite it like that.
Yes. We were just trying to, today in class, figure out logarithms and how logarithms work. And you could tell the students who knew their exponents, you know, 2 to the power of 3, 2 to the power of 4, because they could see the patterns right away. And the ones that didn't know it, they couldn't see the patterns.
Yeah, so.
Or they did eventually, but.
But you spend like maybe 10 minutes right now memorizing these values, and you save like 5 minutes every time you do a problem.
Yep.
So
true.
It works out. Divided by 2 to the power of y. We got the same base, and I wrote this out because I wanted to show and kind of split that this is 8, and we're still raising 8 to the power of x. So we're going to rewrite this now again as 2 to the power of 3x, because when we take a power and raise it to another power, then you multiply the powers. Divided by, oh, I see where this is going now.
I think I do too.
Yeah. So this is why sometimes you look at these problems.
I do see where this is going.
Actually, we know the answer right now, don't we?
Yeah.
Yeah, okay. So.
You guys are probably like, what?
Yeah.
How do they see that?
Yeah, this is where like you look at this problem and you're like, I have no idea what to do. And then you just start messing around with it. That's actually what I love about math is the problem solving and just trying things and then seeing something happening.
I think it's like playing. Maybe a lot of students don't think it's like playing.
We may have had very different childhoods. So.
A little nerdy over here, but that's okay.
Yeah. So you kind of maybe remember this, let's say x to the power of, like a letter or something, x to the power of 5 divided by x to the power of 3. That's kind of what we're looking at. These have the same base, x and x. So the property that you should know is that this becomes x to the power of 5 minus 3.
Yes.
And if you ever want to double check that, look, you have 5 x's up here. You got 3 down here. Look, these guys cancel out. And you get x squared.
This is also why we wanted to put them to have the same base, because if they have the same base, all of those properties of exponents, they start helping you simplify things.
Right.
And so we were thinking, okay, maybe we could rewrite this or something if we had the same base.
Yeah, and if we didn't have the same base, a lot of students make the mistake of, oh, 8 divided by 2 is 4. But you can't do that. You got to have the same base. So we end up with 2 to the power of 3x minus y. Right? And now what we're saying is, look at that, 3x minus y. Oh, where'd it go? Look, we're kind of given information a little bit differently, right?
Right.
3x minus y is 12. So anywhere we see it, like it doesn't just have to be one variable. If we see something that says 3x minus y, and we see that same thing somewhere else, those are the exact same value.
Transitive property.
Yeah.
Yep.
So we're going to replace this 3x minus y. Let me highlight it. It's a little easier that way. Right here with this 12 right here. And then you end up with 2 to the power of 12.
Which, do you know you're up to 12?
I don't.
I didn't either.
4,096.
I should have known
oh,
that
I knew
because
that
of that
of course,
game, yeah.
So 2 to the power of
2048,
12.
if you've ever played it.
Oh, you should have known it. Yeah, we all should have known it.
Yep.
4,096.
Yep.
And there you go. A very tricky looking problem, but if you know your properties of exponents with same bases, then you just play around with it a little bit, it kind of pops out.
Yes, and that word play is so important.
Right.
You saw Nathan and we looked at that problem to start with, and we weren't really sure exactly how to go about it from start to finish. You just saw us figure it out right there on air. We just kind of played around with stuff that we knew, and then it started to become a little bit more obvious.
Yeah, we could have just as easily said, let's solve for y over here, and then we get negative y equals negative 3x plus 12, and we solve for y, and we plug it in, like that got us nowhere. So let's actually manipulate the other piece of it.
So true. Love playing with math.